Good day, welcome to New Dynasty Academy. Today we will be looking at graphs for the ninth grade. We are going to be building our knowledge from the sections that we did earlier on functions and relations, where we looked at the rules where you're determining the inputs, the outputs using a particular rule. So now we'll be looking at the equation of a straight line, and the equation of a straight line is a build-up from what we did in the previous sections. Now the graph of the straight line is also called the linear function. It is linear because it doesn't have any higher degree than 1. You can see the equation reads y equals mx plus c, where our highest exponent is 1. Hence it is called the linear function, and it is written in this form, which we call the standard form. This is how it is written in the standard form. Now from this equation, there are three things that you can determine. You can determine the x-intercept, you can determine the y-intercept, and you can also determine the gradient of the given function. Now, what is the x-intercept? The x-intercept is the point on the graph where the line cuts the x-axis, and it can be calculated by substituting y equals 0 in the equation of the graph. And that is how you are going to be calculating the x-intercept, by substituting y equals 0 in the given equation. Then looking again at the y-intercept. The y-intercept is the point on the graph where the line cuts the y-axis, and it can be calculated by substituting x equals 0 in the equation of the graph. Now the y-intercept can also be represented by the letter c in the equation y equals to mx plus c. So this tells us that this c, or the constant in the equation, it represents the y-intercept. Now let's say you are given the equation y equals to x plus 5, and you are asked to calculate the x and the y-intercept. Let us go on and start off with the x-intercept. Remember what I said in the previous slide, that for you to calculate the x-intercept, you're going to substitute y equals 0. So you're going to go to the equation there, and you're going to put 0 for y. So that is 0 equals the rest of the equation, which is 2x plus 5. Then we need to isolate the term with x here because we're calculating x. So it means we must remove this constant. How do we do that? The 5 is added in this side, so it means we must subtract 5 on both sides. So I'm going to go on and subtract 5 on the left hand side, where it's going to give me 0 minus 5, which is going to be negative 5, equals to, on the right hand side, I'm going to say 5 minus 5, which is 0. Then I'm going to be left with only 2x. And now I've got 2x, which means x is multiplied to 2. And for us to remove this 2, because we need to isolate x, for us to remove this 2, we need to do the inverse operation, which is division here, because 2 is multiplied. So we're going to divide on both sides. And then in this case, this 2 will take out this 2, and we're going to be left with x. So I'm going to read this equation from the right hand side as x being equals to what I have on the left hand side, which is negative 5 over 2, and that is the value of x when y equals 0. So I'm going to go on and write that in parentheses in the coordinate form, starting with the x value, which is negative 5 over 2, and we got this value by letting y to be equal to 0, and that is our coordinate pair. And let us go on and calculate the y-intercept. So for us to calculate the y-intercept, as I said in the previous slide, we're going to substitute x equals 0. So we're going to put 0 in the place of x. So in the equation, we're going to say y equals 2, and grade 9, you always substitute inside the brackets. Use the brackets when you substitute, plus 5. Can you please remind me, what is the number multiplied by 0? The number multiplied by 0 is 0. So we're going to have 0 plus 5, which is just 5, a positive 5. Now that is the y-intercept. Remember, our standard form is written as y equals mx plus c. And I said that the c here represents the y-intercept. So this c here, it represents the y-intercept. which in this case is the constant here, which is 5. So our c is 5 and c is the y-intercept. So y here is equals to 5, which means that is the y-intercept, and we're going to go on and write this in a coordinate form in parentheses, and you always start with the x value. Remember, we got y by letting x to be equal to 0, so you're going to have 0 and 5 being your coordinate pair. So this is going to be the value where the graph cuts the y-axis, and this is where the graph is going to cut the x-axis. Grade 9s, you can go on and calculate the y and x-intercept by using the equation on the right hand side here. You can pause the video and go on and calculate this. Now let us look at the concept of the gradient. The gradient referred to as the slope of the graph. The steeper the slope is, the bigger the rate of change between the x and the y coordinate. So if the slope is steeper, then the rate of change is going to be bigger between the x and the y coordinate. You might not understand this now, grade 9s, but it is going to be clear to you. And what does it mean when you say that when the gradient is steeper or the slope is steeper, the rate of change is bigger between the x and the y coordinate? Now this is also represented by the letter m in the equation y equals mx plus c. So this letter m represents the gradient. So how do we calculate the gradient? It is calculated by using the equation, for this following equation: y equals change in y values divided by change in x values. Or in short form, you can just say the gradient, which is m, is equals to y2 minus y1 and x2 minus x1. So these are the x and the y values from the two given points. So it means for you to be able to calculate the gradient, you need 2 points. As you can see, there's a y1 and y2, x1 and x2. So it means you need 2 points for you to use this equation. Now, a positive gradient has the upward slope, and it is called the increasing function because it is increasing. As the x value is increasing, the y value is also increasing. The negative gradient has the downward slope, and it is also referred to as the decreasing function. Now, the bigger the gradient, the bigger or steeper the slope. Now, continuing with the gradient, we have here the graphical representation of what we read in the previous slide. Yeah, we can see here we've got the increasing function. In the increasing function here, we say that our gradient is positive. That shows the positive gradient. Now the line slopes up from left to right. Grade 9s, you always read your graph from left to right. So as you can see from left to right here, the graph slopes up. It slopes up from left to right. So as that is happening, notice how the x values are increasing and also the y values are increasing as well. Now we say that the graph is increasing or it is ascending. Now moving on the right hand side, here we call this the decreasing function for the negative gradient. Now what you see here is the line that slopes downwards from left to right. As I said, you always read your graph from left to right. So from left to right, you see that it is sloping downwards. Now notice what is happening when you're moving down from the left to the right hand side. What is happening to the x values? The x values are increasing because you're reading x from the left hand side to the right hand side. So the x values are increasing, but what is happening to the y values? As you're going down here, what is happening to the y values? They are decreasing. So the x values are increasing, but the y values are decreasing when you're going down the slope. Now we say that this is a decreasing or descending function. Now let us say you are asked to calculate the gradient. Remember the formula for the gradient? Remember, who can remind me what was the formula for the gradient? We denote the gradient by the letter m. Then the equation was y2 minus y1 divided by x2 minus x1. Now grade 9s, you can choose the notation for yourself here. Now I'm going to note this a values as x1 and y1, and the b values as x2 and y2. That is totally up to you. You can denote your a values as the 2's and the b values as the 1's. It's totally up to you. Then you're going to substitute the values that you have chosen. So we have chosen this y2 to be 3. So we're going to substitute y2 as 3 here and subtract y1, which is 5, divided by x2, which is negative 1, and subtract 2. And how do we subtract? You can just use a calculator here, but 3 minus 5, that's going to give us negative 2, because that is the smaller number, subtract the bigger number, and negative 1 subtract 2, that is going to give us negative 3. So the negative sign by division are going to cancel each other, so we are going to have our final answer being 2 over 3, and that is how you will be calculating your gradient, grade 9s. Then furthermore, when the y-axis variable remains unchanged while the x-axis variable changes, this will cause the graph to be parallel to one of the axes. Now, basically, this sentence, it may not make sense. Basically, it's talking about this one here. You see that on this graph here, the y variable or the y-axis remains unchanged on this line. We're talking about the line that is darker than the other two lines, because the other two lines represents the axis. They represent the axis of your Cartesian plane. So we're basically talking about this darker line here. This is where the y variable remains unchanged, and you can see that when you're moving from the left hand side to the right hand side, what is happening to the x-axis? The variables are increasing. So this causes the graph to be parallel to the x-axis. This represents the graph, and that is the x-axis. Now the property of this graph is that the gradient of this graph is equals 0. It doesn't have the gradient. Now the example is that y equals 5. So if the value here is 5, it remains 5 all through, and it makes these lines to cut the y-axis at 5, and this line also to be parallel to the x-axis. Now on the other hand, on this side here, this is where when the x-axis remains unchanged while the y variables are changing here. But for this line, we cannot have the gradient. The gradient of this line is undefined. Example, if x equals 3 here, you can see that x will always be 3 while the y values are changing, either going up or going down. And this line cuts the x-axis at 3, and it is also parallel to the y-axis. So when you compare these two, you can see that this one has got the undefined gradient, so it means all the vertical lines will have undefined gradients, while the horizontal lines will have the 0 gradient. Then in this picture, we can see that we have got a line that is cutting the axis on both axes. So it says here, if the line cuts the x and the y axis, then the equation of the line will contain the x and y. As you saw on the previous example there, we only saw the example where y equals to 5 and x equals 3. But in this case, that was happening in that case because the line was cutting only at one axis at a time. Now in this case, the line cuts the y-axis at -2 and cuts the x-axis at 2. Hence the equation here is written as x equals 2 minus 2x minus 2. So what you see here is that this equation contains the x and the y because it cuts the axis at both x and y. Now, the example that we have here, the first one, it says sketch the graph of the linear function given by the equation y equals 2x plus 3. Now, what you use here, grade 10, is the table. So what you normally do, you can choose the x values, which we call them the input because you choose them, and the chosen values are going to be substituted in the equation that you are given. Then you're going to determine the output as we used to do when we were doing functions and relations. So, but I can just go on and do a few for you. In the equation y equals 2x plus 3, let's say we choose negative 3 as our x. So we're going to substitute x for negative 3. I mean 3 for negative x. That is negative 3, sorry. That is negative 3. And you always substitute inside the parentheses. Plus 3 here. This is what we have. Then we have got 2 multiplied by negative 3, which gives us a negative 6 plus 3. Then when you go on and add this, you get negative 3 as your answer. So this is where this negative 3 comes from substituting this value and getting the input value and getting the output. So some other this has been done for you, and you can see that this is going to form the coordinate pairs. So you're going to have the coordinate pair, like the first ones here, they're going to form a pair. So you take this pair here, you point it in the graph, so you put them as the point in the graph. So the x value is negative 3, so here is our negative 3 for the x value, and the y value is also negative 3. So the point is going to be there. So that is going to be our first point. Our next point is negative 2 and 1, and negative 1, which is this point. Our next point is negative 1 for x and 1 for y, and which is that point there. And 0 and 3, 1 and 5, you can see that the line has already been drawn for you. So basically, before this green line has been drawn for you, you have this point which you join them together to form this line. So if this line was not drawn for you, this is what you are supposed to be doing. You put the points on the graph and you join them together, and they're going to form the straight line. And grade 9, that is how you draw the straight line function or the linear function. Example 2, it reads, use the equation y equals negative x plus 4, complete the table and write down the ordered pairs. Plot the points on the Cartesian plane, join the points to form a straight line. Grade 9, that is the procedure. And this should be the procedure that you always follow for you to be able to sketch the graph of the linear function. So the first thing that we're going to do here is to complete the table. So how do you complete the table? We're going to use the given equation y equals negative x plus 4. So let me write it down here. Y equals negative x plus 4. Remember, we have chosen already the x values, which as our input values or the independent variables. They are the independent, and we're going to calculate the dependent variables, which are the y values. So from the equation, we have got a negative sign, and we're going to substitute a number with a negative sign also. So grade 9s always use the bracket for that purpose. Remember in grade 8 when we studied about the use of the brackets, one of the uses of the brackets is when we are substituting, and another use is for you to separate the signs. So you can see we've got the negative sign. We can't just write negative 3, so we putting negative 3 inside the brackets because we want to separate the signs. But now this brackets now will have a particular function, which is multiplication. Then we're going to multiply negative, which is negative 1 in this case. So it is negative 1 multiplied by negative 3. In negative terms, negative gives you positive, and 1 times 3 obviously gives you 3. Then you add that 4, and then your simple addition here, you get the sum of 7. That should be clear. Then the next one, I'm not going to do all of them. I'm just going to do the next one, and you will continue with the others. I'm going just to substitute here. We've got the negative sign from the equation, then we're going to substitute -2. Then we add 4. This equals, as we know that the signs are going to multiply out to give us positive, and that is going to be +2 plus 4. And that sums up to 6. So you can pause the video and continue filling up the table. As I'm going to fill up the table, let me use a different color for that purpose. The first value here is 7, and then we're going to have 6 here, and then 5, 4, that's obviously 3, we're going to have 2 here, and we're going to have 1 there. I believe that I'm correct. Now here we've got our ordered pairs, which the instructions said that we should complete the table and then write down the ordered pairs. We do have our ordered pairs there, and then we're going to plot the points on the Cartesian plane. Let's go on and use the Cartesian plane to point, the table to point on the Cartesian plane. We've got -3 and 7, -3 for x, -3 for x, we're going to use this. That's -3 for x there and 7 there, so they form a point there. That's where the -3 and 7 meet. And the next point is -2 and 6, and that is a point. And this point, I'm taking this point from the table as they are from the table. That is going to be 2 and 2, and the last point 1 and 3, 3 and 1. So that's basically how it is. So after doing this, you join this point together. Then that is going to form a straight line, and that is how simple it is for you to draw the straight line, grade 9s. It is quite an easy task to do. It is not really difficult. It is quite an easy task to do. So I cannot do it here very well because I'm not really artistic, but I believe that you can and you will do it perfectly. So I can try, but let me try to join these points together. I tried, yes, and that's it. Yes, and that's how you draw the line. And remember, that is a graph which is continuous going down and continuous going up, and that is going to be the straight line. And in some teachers will tell you that you must also name this. You must give the name. That is the straight line of the equation y equals -x plus 4. And that's how you do that, grade 9. So that's how simple it is to plot or sketch the straight line graph. Then moving forward, that is the last slide there. The last slide here, it is your activity. It reads here: sketch the graph of the following functions, complete the table and write down the ordered pairs, plot the points on the Cartesian plane, join the points to form the straight line. And those are the given examples. Grade 9s, it was pleasure if you watched this video until this end. I want to thank you. You can do this activity depending on where you are watching this video, either on YouTube, Facebook, Instagram, or TikTok. You can comment, you can DM us, you can ask us questions, you can tell us which is the next topic that you want us to do, and you can join our program also. You can just DM us, then we'll give you all the details. If you want tutoring, private tutoring, we've got tutors who are qualified to give you that in various subjects. From me, thank you. See you in the next one.